Lesson 111. In this lesson, we're going to use the concept of benchmark fractions along with the technique of rounding, which you have known for many years now, to apply it for the purpose of coming up with a quick estimate when we are in this business of adding and subtracting fractions. First, a benchmark fraction. In this chart in the upper left, 0, a half, and a whole are referred to as benchmarks because you can visualize them in your mind. You can picture them on a number line. Let's see how those benchmarks of having those visual locations or values in your mind can be put to use here. Again, our task in this first practice problem is to imagine that we are asked to come up with a quick estimate for adding 1/6 plus 7/8. We might first think about where 1/6 is on the number line, somewhere between 0 and a half, and then determine, well, it's going to be closer to the 0 side. 7/8, on the other hand, is between 1/2 and 1 on the number line and closer to the 1. So if we put those understandings together, a quick estimate for this problem would be to say that 1/6 is close to 0. 7/8 is close to 1. So when we go to add them, we're going to get an answer that's about 1. Take a look at this chart now in the upper right. We're using rounding and benchmarks to estimate 4 2/5 minus 1 5/6. When we think about the number line, think about the number line as having whole numbers, having the halfway point between those whole numbers marked off as well. In this case, 4 2/5 is close to 4 1/2. 1 5/6 is close to 2. So put those understandings together without taking the time to actually solve 4 2/5 minus 1 5/6. We can come up with a quick estimate to say that our answer is going to be in the ballpark of 4 1/2 minus 2, or 2 1/2. Let's practice these. Number 1, 8/9 minus 3/8. For each of these, we're going to come up with a quick estimate first, and then we're actually going to solve to find the real answer, the actual answer, and determine were we close or not. The word difference here is just meant to show that we're dealing with a subtraction problem. And I'm taking a quick look at this whole page, and I think that's a typing error, because on this page we're adding in some cases and subtracting in some cases. So it probably should have said sum over here and sum over here and sum over here instead of difference. So for our purposes, we'll just ignore the wording there. For each of these practice problems, we're first going to do the quick estimate, then we're going to solve to find the actual answer, and we'll compare the two. Number 1, 8/9 minus 3/8. Well, 8/9 is close to a whole. 3/8 is close to a half. So 1 minus a half, our estimate is going to be a half. Now let's actually solve this. We're subtracting two fractions. 9 and 8 are the original denominators. 9 is the larger of the two, but 9 is not a multiple of 8. So I'm going to list out over here my multiples of 9 until I find one that could work for the 8. Hmm. 72. Took me all the way to 72. All right. So 8 over 9 is going to be rewritten as something over 72. 3 over 8 is going to be rewritten as something over 72. What I do to the bottom, multiply by 8, I must do the top, multiply by 8. This becomes 64 over 72. What I do to the bottom, multiply by 9, I must do to the top, multiply by 9. Now, the denominators match. Let the numerators do the work. 64 minus 27 will get me 37 over 72, final answer. Some higher powered number crunching there. Nothing we couldn't handle though. Number 2, come up with our, before I go on to number 2, let's take a look. Is 37 over 72 a reasonable answer based on our estimate? Well, it is, because the truth is 36 over 72 would be exactly a half. So this is very close to our estimate. Now on to number 2. Come up with our estimate first. 2/5 is close to a half. 5/9 is also close to a half. So our estimate is 1. Now let's solve this. Our denominators are 5 and the 9. Again, I'm going to go through my multiples of 9. 9 won't work for 5, but 9, 18, 27, 36, 45. 45 is our winner. So I'm going to rewrite both fractions having 45 as the denominator. Over here, I'll multiply bottom by 9. We'll multiply the top by 9. Over here, I'm going to multiply the bottom by 5. I'll multiply the top by 5. Add them up. I get 43 over 45. Number 3, our estimate, 1 1/8 is close to plain old 1. 1 5/6 is close to 2. Round that up. So our estimate is going to be 3. Oh, sorry, once again, I jumped ahead here. After I'm solving these, I should take a moment to just compare to my actual. In this case, you can see our estimate was really close, once again, to our actual. Back to number 3. Common denominator between the 8 and the 6 feels like 24. So I'm going to rewrite 1 1/8 by multiplying the bottom and the top of the fraction by 3. I'm going to rewrite 1 5/6 by multiplying the bottom and top of the fraction by 4. I'm going to get a final answer of 2 and 23 over 24, which is very, very close to our estimate. Number 4, for our estimate, 3 5/8 is close to 3 1/2. 1 1/6 is, we'll round that down to plain old 1. We'll get an estimate of 2 1/2. Again, the common denominator here of 24 seems to be a good fit. So let's rewrite 3 5/8 by multiplying the bottom and top of the fraction by 3. Let's rewrite 1 1/6 by multiplying the bottom and top of the fraction by 4. And we'll get an answer of 2 and 11 over 24. very close to our estimate. Number 5, 1/10 plus 4/5. For our estimate, 1/10 is, well, it's very small. It's close to 0. And 4/5 is close to a whole. Our estimate is 1. For the common denominator, 10 seems to work. So 1/10 stays as is. 4/5 gets rewritten by multiplying the bottom and top by 2. We get an answer of 9/10. That is very close to our estimate. And finally, number 6, 9 and 9/10 minus 3 and 2/9. Well, 9 and 9/10 is almost 10. 3 and 2/9 can get rounded down to 3. So my estimate is 7. Common denominator in this case would be 90. So for 9 and 9/10, we're going to multiply the bottom by 9, so we'll multiply the top by 9. For 3 and 2/9, we're going to multiply the bottom by 10, multiply the top by 10, and finish the job. And we can see we were reasonably close to our estimate.